Okay, now we've got distance. Let's have a look at time. Let's say, for example, we're working on a therapeutic AR program where you want the user to move their phone at a consistent speed of their choosing, but you want to make sure that they're staying at the same speed no matter what they're doing. We're gonna need two pieces of information. One of them is a distance, which we've already worked out. The other one is how long it took them to move that distance. And for that, we're going to need something called delta time. So let's go ahead and have a look at delta time. It's very much like delta distance. We work it out in the same way. We use something called elapsed seconds. So if this is elapsed seconds, and we say, oh, okay, well, the first frame was at second 0, and let's say we've got a really slow computer where it takes 2 seconds to render each frame. Next frame's at 2, next frame's at 4, this sort of thing. Well, let's say we've got a frame at 6 and a frame at 4. We could just say if that's B and this is A, we just say B minus A is our delta time. So 6 minus 4 is 2. It took 2 seconds for a frame to occur. So we say delta time equals 2. Once we have delta time, we then need to look at delta distance. We then need to look at distance. So let's say our distance that we've calculated is maybe 5 meters. Okay, so our distance equals 5 meters. Now what that means is if you've moved 5 meters in a frame, and the frame took 2 seconds it was 2 seconds between frames, then you've moved 5 meters in 2 seconds. Now what we do is if we take our distance, I might write it over here. If we take our distance and we divide it by our delta time, distance over delta time, that'll give us if we're working in meters and seconds, that'll give us our meters per second. Okay, so if that's 2 seconds and 5 meters, 5 over 2 that's saying, you can think about it, right? If it took you 5 meters, in 2 seconds to travel 5 meters, then in 1 second you travel 2.5 meters. It makes sense. Okay, so 5 over 2 equals 2.5 meters per second. Now, usually we're going to be working with far smaller numbers. If we've got a very fast computer, maybe it's 60 frames per second. And maybe the size of these vectors would be very small, like, I don't know, a fraction of a centimeter. So for speed, we're first going to need to figure out our delta time, how long it is between each frame. Now we know we got 3 frames per second, so we could work that out ourselves. But just in case we were doing it on a constant frame rate that we didn't know about, we're just gonna do a manual method. So let's go ahead and have a variable we'll call last time. Let last time equal, just say date.now. That's a function that'll return, I think it's like the current milliseconds since 1970 or something. Doesn't save, it's something like that. So that'll be the time of the last frame. So now we can say, let's go speed. So we say let time equal date.now. And then we can just say let delta time equal time minus last time. It's very much like distance, the current time minus the last time, and that'll tell us how long it's been. Let's see, dt. I'll just say dt equal time minus last time, and then I'm going to make sure I remember at the very end. Just say last time equals time. Remember to do that. Okay, well, let's just test that out. See what sort of numbers we're getting out of it. We should be able to work it out. If it's 3 frames per second, a frame should last for a third of a second. So let's see if we're getting that. Let's see delta time, and then we'll just write in dt.to fixed. I'm going to give it a few decimal places, maybe 3 decimal places. Okay, Yeah, okay, so it's in milliseconds, 333 milliseconds per for distance between each frame. I'm gonna go ahead and change that to seconds. And a really easy way to do that is just divide the whole thing by 1,000. Okay, so we've got 0.3 frames per sec. 0.3. The delta time is 0.3. Our distance is, let's see, if our distance is like 100, then we just say, I'm just going to go ahead and write the formula out so I don't get confused. We're going to say our speed equals our distance over delta time. Okay, so let's go ahead and write that out. Well, I mean, let's see. Actually, I really should figure out if I can do it in my head first. All right. So if we've got let's say we've got a distance of 100 and it took us 0.3 seconds to go 100 pixels. Then in 0.6 milliseconds would go 200 pixels. In essentially 1 second would go 300 pixels. So it should be 300 pixels per second if I'm going at about 100 pixels each frame. Okay, so let's see if we can do that. So we'll go ahead and say let speed equals dist over delta time, and we'll go ahead and print that out. Okay, you go speed. We shouldn't need decimal places for speed. Okay. I'm not sure what. Yeah, we don't need delta time x. Just say delta time. All right. Give that a go. Speed is 0. Okay. So, yeah, if our distance is about 100, we're getting about 300 pixels per second. In fact, I should write let's write the units so that we really know what we're talking about. Pixels. And speed would be delta time seconds. Speed would be pixels per second. Okay.